Hi students, today we're talking about trig models. We've already done some going from data to trig equations. Today we're going to do it without kind of seeing it in trig graph form. We're going to look at two different types of models today. The first one is a tide model. So I've got some data points and I've graphed these data points down below just to show us why we use trig for this. We know that, or you may know that, living in New England, tides are a cyclic thing, so we can use something that would repeat itself in order to make predictions with them. And we can see that this kind of looks like a sine or cosine graph and may be pretty helpful for us. What we need to do is remember where our pieces of our trig equation came from. So if we've got a general equation of a cosine of bx minus c, and then plus d. And by the way, we will be using cosine for these because it's easier for us to find max or min points to work with. So for example, my maximum point appears to be at 10 based on my graph, and I understand that that's at 7.6 as a height. So we can work with some stuff like that. Let's talk about what these pieces mean in terms of the parameters for my trig equation. Since I've already identified the max value, so I'm going to call this the max y value. In this case, that's going to be at 10, 7.6. The x becomes the c value. The reason for that is that we're dealing with the phase shift here. Phase shift is an x characteristic. So once we find that maximum value, we have to use the x to get there. So the equation I'm going to build from this is going to be x minus 10 on the inside. Okay. The second thing I've got to identify is my b value. So the b value we said was related to the period, and if we write this as 2 pi divided by the period, that's going to let us very quickly jump to an equation for this. The way that I'm going to figure out the period would be thinking about the highest and lowest points. And here I can see that I have 2 points that appear to be at the lowest part of these tides. I don't see where my second point for the highest would be. So I'm going to have to use the low ones. And when I look here, I want to do x minus x. So let me put that as x2 minus x1 so that these don't get too confusing. And I'm going to describe this as like low minus low or high minus high. When I look at these 2 points, I've got 4 a.m. and the next lowest point appears to be at 4 p.m. It's not quite as low, but it's pretty close. Between those two, I've got 12 hours. So for this particular situation, B is going to be 12 hours. So I'm going to write this as 2 pi over 12. I'm just going to try to move some stuff around, although I don't know that it's going to let me do that because I'm in a weird program. That's okay. I have this written on the next page anyway. All right, to get some of the other stuff, we know that the midline is got to be in the middle of our graph. So I'm going to think about the midline as the average of the highest and lowest. And now I'm talking about y values. So we've got the lowest of 0.7. The highest appears to be at 7.6. I think that's what I had written before. And divide that by 2. That's going to give me the average of the highest and lowest, which is going to be the midline for this graph. So if I were to write this as 0.7 plus 7.6 over 2, that's really helpful because I can see where that comes from and gives us a nice clean value for that. We said this is going to be a cosine function, so I'm going to put that cosine part here. And then last thing we need is an amplitude. The amplitude is the distance from the midline to the top or the midline to the bottom. Another way to think about that is if I know the distance from the top to the bottom, I can cut it in half and find out what that amplitude is. So I like to think about this as the highest y minus, highest y minus the lowest y, lowest d, divide by 2. So it's really similar to midline, but we're subtracting those values instead of adding them. So we're not finding the average, we're finding half the difference between them. So just like we had before, this is going to be 7.6 minus 0.7 instead of plus, divide by 2. I'm going to put that out front. 7.6 minus 0.7, divide by 2. That's really hard for us to see. I'm going to look at the next page, which has this done out in Desmos and graphs that equation based on the points that we have here. We can see this is a pretty nice fit. For some reason I did 0.8 instead of 0.7. I don't really know why. You also can't see the end of this equation for whatever reason, but the end of this has that same expression we looked at, 7.6. I'll just say 0.8 because that's what I wrote at the beginning. Divide by 2. That's just a typo as I was putting that in. If we want to think about this in terms of a general idea here, our equations are going to be like max y minus min y divide by 2, cosine, going for stuff on the inside, it's always going to be 2 pi divide by the period, so we can describe that as period or the length of that cycle. I'm going to keep going. We're going to have x minus, and I'm going to describe this as the x coord of the maximum, and that could be any maximum because these repeat themselves. And then finally, we need our midline, which is going to be the max y plus the min y, sorry for the tiny writing, divide by 2. So it's the average of the highest and lowest point. All right, what I'd like to do is to see if we can use this format to go to the next page. And I'm going to see if it let me copy this. I did. Copy. Okay. Oop, it's copying. I don't know why that took as long as it did. I'm going to try pasting this here. And here we're going to have a new data set. This is the average temperature. And I think this is average max temperature in Danvers over the course of a year. This is a couple of years ago, so it probably is a little bit higher based on average global increase of temperatures. But let's do this same idea here. So I'm going to find my max y, and that's going to be, okay, nope, 74, 80.1, okay. So that's going to be at 7, 80.1. That gives me a couple of really important points. The first is that the x-coordinate of the max, that's going to be 7. The second is that gives us part of what we need for the beginning and the end of this. All right, so now let's do the minimum y. So the minimum y, probably January or February maybe. It looks like January, and that's going to be at 1, 34.4. This is going to give me a couple of really important points. It's going to give me the min y values that I need for the beginning and the end, and it may also give me an idea of the period. We can also use some common sense to think about how long does the cycle of temperatures over the course of a year take? If you said that it takes a year, you would be correct. Since we're going by month, let's say that the period here is equal to 12 because there are 12 months in a year. Okay, let's build our equation. So we need a max y value. That's going to be 80.1 minus a min y value, 34.4, divide by 2. That's my amplitude. Cosine. We need 2 pi over 12. The next parentheses is really, really important. And that's going to be x minus the x coordinate of the max we said was 7. And then finally at the end, we need the same thing as we had at the beginning. I'm going to erase that mess that I just made of that. And that's going to be 80.1 plus 34.4 divide by 2. You certainly can simplify the beginning and the end part to get those to be nicer looking decimal numbers if you want. I kind of like leaving them like this because I can see where they came from, and that makes that a little bit easier to process.